Hello all. Hey, welcome back to Archbishop Murphy. Hope everybody's doing well, and hopefully soon we'll actually get to meet in person. So I'm Mr. Munchak, and I'll be putting together the homework reviews for Mr. Woodworth's basic geometry course. And I'll be posting this video as well as the written problem solutions to the course's Moodle page, so you'll be able to see it there after the homework has been completed. Okay, this first review, we're going to look at the homework assignment that was section 1.2, pages 16 through 19, and I'll break this into two parts. The first part I'll look at problems 8 through 14, and then the second part I'll cover the remaining problems. So first thing I want to do is a quick recap. I just put a little sheet together here, and the basic definitions: point, plane, line, ray, and segment. So our points, we indicate it's a zero dimension, just dot, and we usually have a capital letter A, B, C, whatever, with a circle, a dot underneath it. That indicates it's a point. Planes, we usually kind of indicate it looks like a sheet of paper with, again, another capital letter, and this time there's no dot under it, so that indicates it's a plane, and planes are in two dimensions. Then for our lines, we have lines that extend in two directions. Okay, straight line, and that's one dimension, and we indicate that with 2 points on the line, in this case A and B, with a double-headed arrow over the top. If I'm talking about a ray, then I'm talking about a line only extending in one direction from an endpoint. So in this example, endpoint A extending in the direction B, so I indicate that as, again, an AB, but this time the arrow over the top has just got one arrow point on it, and it points in the direction. And a line segment does not extend. It's just a segment, a portion of the line in between the points A and B, and so I just have a straight line over the A and the B in that case. Okay, that was the quick review. So now let's look at the homework. All right, so first of all, let's look at problems 8 through 11, and this figure here is what I copied from the book, and it shows, first of all, you have a plane C, and then there's a line that has indicated with a small n, and also 3 points, E, B, and F, and then another line that goes through the plane. It's not part of the plane. Another point that's on the plane, G. And that figure is what we'll do for the first few problems. So first of all, number 8, what are other ways to name the line EF? Well, we can name it FE because the order doesn't matter because it's extending in both directions, or we can use that lowercase n, which is also the name of the line. In this case, because B is collinear, it's part of the line, there are other possibilities as well. We could name it EB, BE, BF, or FB. All those are valid. And again, I have the double arrow over the top. Okay, how about question number 9? What are 2 ways to name the plane C? Well, any 3 points on the plane are all you need to name one. So if we look, and the points cannot be collinear, not on the same line. So if we look, they have the 3 points, G, and any one of those 3 that are on the line. So GEF, GEB, or GBF would all work. And why can't I name a plane by 3 points that are on the same line? Well, here you can see I have 3 points on this line, and there are multiple planes that go through it. In fact, there's an infinite number that kind of go through at every angle. So you can't have the 3 points on the same line. They have to be on a different 2 on a line and 1 somewhere else. For number 10, name 3 collinear points. That means on the same line, and again, we saw we have E, B, and F. For number 11, name 4 coplanar points, and again, on the plane, so any points that are on this plane, that's G, E, B, and F. Now let's look at 12 through 14. And you see up here there's a figure for that too, which I kind of copied and I repeated elsewhere, but it's a line with 4 points on them, R, S, T, and W. So the first thing it says is name the segments in the figure. Well, to do this, what I would do is just pick a particular point, call that the endpoint, and then list all the other segments that go to a different endpoint. And then I repeat that for all the lettered points. So here I start with R, and R can go to S, it can go to T, or it can go to W. So R can go to S, T, or W. So it's 3 different segments. Then I go to the S point, and same thing. S can go to T, or S can go to W, or S can go to R. But I already listed the SR term as RS, so that's kind of a repeat. Then I move on to the T, and T can go to W, or it can go to T to S, and T to R. And again, those were already listed. And finally, W itself can go back to all 3, WT, WS, and WR, but we listed them going the other way. So you see the unique ones here, I kind of put the box around. RS, RT, and RW, ST, SW, and TW. And then the other ones are different ways of naming it. And in the figure, I've kind of broken out what they are. So you can see here those segments, then the segments that kind of cover 2 points, and then the big segment that covers the entire section. So there's 6 altogether. Number 13, name the rays in the figure. And again, I do the same sort of thing. I'll pick an endpoint, and then I'll write down all the rays that extend from that endpoint. So start out with R, and R can go towards W. And I can name that a bunch of different ways. RS, RT, RW, they're all the same because it's an array going in that direction. Now I can start with S, and with S now I can go in 2 different directions because it's in the middle, S towards R or S towards W. And so I have SR and the SW, which can also be written as ST. The T point is also the same. It can go in 2 directions because it's in the middle. And so I have TW and TR, which can also be written TS. And the last one is the endpoint. W, and W can only go in one direction because it's at the end, and it goes in the R direction. But it can also be written different ways. For 14, it asks you to name a pair of opposite rays. And so an opposite ray is, again, you have an endpoint, and rays extend into both directions from that endpoint. So we have T that has the endpoint T, so TW and TR. And that's that case right there. So the T goes that way or that way, so TW or TR direction. Then for B, they ask you to name another pair of opposite rays. Well, that's the other middle point, S, and S can go towards the R or it can go towards the W. So again, you have those 2 sets. And that's the first part of this problem set, and I'll be doing the second part in a second. See ya.